All right, so in this problem we have an 800-gram ball traveling with a velocity of 5 meters per second, and it strikes the ground at an angle of 40 degrees from the horizontal, and then rebounds from the ground with the same velocity of 5 meters per second at an angle of 40 degrees from the horizontal. The first question is, find the impulse of the ball during the collision with the ground. Now, impulse is the same as change of momentum. So what we're looking for here in this first question is basically the change in the momentum. Now, before we start solving for it, what we'll do is take a look at these velocity vectors. So when the ball hits the ground, we're going to do this in red. As the ball comes in, it has a y velocity and it has an x velocity. So I'm showing the components of the velocity. When the ball leaves the ground, it has x velocity and y velocity. Now let's calculate what these are. So using trig, so we have this 40-degree angle right here. This makes a 90. So we can solve for Vy initial. Vy initial before the ball hits the ground is negative 3.2139. Negative 3.2139 meter per second. And I got that just using sine. Sine of 40, sine 40 times 5 gives this opposite component here. And then this x component, Vx initial, comes out to be positive 3.8302. 3.8302. So I'm not showing the calculation, but this is just trig. I used cosine here, cosine 40 times 5. This x component, after the ball leaves the ground, the x velocity final comes out to be positive 3.8302. Again, cosine 40 times 5 gives that value. And then Vy final, after the ball leaves the ground, is positive 3.2139. 3.2139 meter per second. And again, the sign conventions, the sign convention I'm using here is up is plus, down is minus. That's why this y initial velocity is negative and this y final velocity is positive. This vector points down, this vector points up, and then in the horizontal direction we have to the right is plus, to the left is negative. So there's our sign convention. Okay, so the key part of this problem is recognizing that in the x direction there is no change in velocity. This initial x velocity is 3.8302. The final x velocity is the exact same thing. So there is no change in velocity in the x direction. Now if we look in the y direction, there is a change because the initial y velocity points down and the final y velocity points up. So the thing to recognize here is the change in velocity is only in the y direction. In other words, the acceleration here points straight up. The acceleration of the ball, it's only in the y direction. The ball comes in with a negative y velocity and it leaves with a positive y velocity. That's an upward change. And in the x direction, there is no change. So our change of velocity, which is only in the y, we're going to go v final, and that's vy final, minus vy initial. Change is always final minus initial. So our final y velocity is 3.2139 meter per second, minus the initial y velocity, which is negative 3.2139. So what happens here is these negatives cancel, and our change in velocity is positive 6.4278. Positive because the change of velocity is straight up. So, because the change of velocity is in the y direction, that means the change of momentum is also in the y direction. You know, recall that momentum is simply mass times velocity. Mass times velocity. So the change of momentum, which is the impulse, that's what we're solving for, the change of momentum is in the same direction as the change of velocity. And the change of velocity was in the y direction. So the change of momentum is going to be mass times change of velocity. Remember, in this class, any change of momentum is going to be the result of a changing velocity. We're never going to have a changing mass. So our mass is 0.8. We figured out that the change of velocity is positive 6.4278. And this gives us an impulse, or a change in momentum, of positive 5.142 kilogram meter per second. And that's directed straight up in the y direction. Straight upward. It points that way. The change of momentum is straight up. Okay, so the second question, now that we have the change of momentum, we can use Newton's original second law. We'll do it over here. So here's number 2. Newton's original second law is F net equals change of momentum over time. So if we're solving for the net force of the ground on the ball, we're going to take our change of momentum, which we already know, 5.142 kilogram meter per second, and we're going to divide this by the time, which is 0.006 seconds, and that gives 857 newtons. So actually, this is the net force. I just realized the question says the average force of the ground on the ball, which is a little bit different than the net force. So let's just change this to the net force on the ball. We're going to change this question here. The net force on the ball.